Good evening, students. Today this topic is going for 50 minutes, image segmentation. In this topic to be covered from the following topics, especially the detection and discontinuities, and edge linking and boundaries detection, threshold, especially the region-based segmentation, and segmentation by morphological watersheds, the use of motion in segmentation, image segmentation based on colors. So in this case, out of this is the image, the parts of this image segmentation, some type of codes are there, implicit and max Vertimer. That is, the whole is equal to the sum of its parts, but the whole is greater than the sum of its parts. So in this previous concept, we'll come to say the type of these values, the two basic properties of this image intensity value is, one is discontinuity and another one is similar. In this first category, the approach is to partition an image into region based abrupt changes in intensity, such as edges. Another one approaches in the second category based on partitioning an image into regions. So that is called similarity, similar according to the set of defined criteria. So here this type of names are thresholding, region growing, and region splitting and merging, and examples of methods in this category for region-based approaches. So in this concept, this we come to collective of these chapters. First we'll move to fundamentals. For example, mathematical representation or represent this entire spatial region occupied by an image, we may view image segmentation as a process that partitions R into n subregions R1, R2 up to Rn, such that different category for union I equal to 1 to n, R of I equal to R, and then B is the Ri is a connected set for I equal to 0 to n, and the intersection, the common set will not be null value for all I and j. I is not equal to j. Q of Ri equal to true for I equal to 0 to n. Q of Ri union Rj equal to false for any adjacent region Ri and Rj. So in this case, you will come to the so many concepts here will be highlighted from Rk and pi is a null set. The symbols union and intersection represent the set of union and intersection. That is the symbols of a region Ri and Rj is the two region adjacent the union form to be connected in the set. It is set formed by this union of two regions not connected. The region are set to disjoint. So what are the conditions to be applicable here? A indicates that the segmentation must be complete in the sense that every pixel must be in the region. Condition B requires the points in a region B connected in some predefined sense. Example, points must be 8 connected. Condition C says that the region must be disjoint. Condition D deals with the properties that must be satisfied by the pixels in the segmented region. So in these connections, you will come to connected over to group of each and every region for adjacent region, especially Ri and Rj. Thus we are be connected from the basic category dealing with the property intensity values, discontinuities and similarities. So next we'll move to the local discontinuities is in intensity edge-based segmentation. The major principles to be approaches from region-based or edge-based segmentation. Edge-based is the discontinuities in intensity. Region-based segmentation approaches in the second second category. Again, predefined region-based regions are be partitioned to this regions. So illustrated from the different type of example shown in this figure here. Say that the image constant intensity region. B is the boundary, only to highlight the intensity discontinuities. Here this discontinuities. C is the result of segmentation, to be foreground and background. We say this is the type of result of segmentation. and D is the image of texture region, and E is the result of intensity discontinuity computations. It violated here. Finally, result of segmentation based on region properties. So these are the things will come to analyzation from the type of figures. So normally, if we come to say the different type of analyzation area analyzed, we'll come to say the type of point, line, and the edge direction. So these are this important to focus from detections of sharp local changes in intensity. So these are to be connected over to the type of studies. Normally, any interested or isolated points, lines, and edges, edge pixels are pixels at which the intensity of the image changes abruptly, and the edges will come to the edge segmentations or set of connected edge pixels. Edge detectors are local image processing tools designed to detect edge pixels. A line may be viewed as a typically thin edge segment in which the intensity of the background on either side of the line is either much higher or much lower than the intensity. So it is called as the roof edges. Already study about this horizontal, vertical, and then ramp and step, and then totally to connected with the ramp and step, you will come to step and ramp connected with the roof edges. So we'll come to say analyzation from the background studies. What is the major orders of finite difference? The first derivatives will come to analyzation from approximation of first rule must be zero in areas of constant intensity, must be non-zero at the onset of an intensity step or ramp, must be non-zero at the points along with the intensity ramp. Similarly, we require that an approximation used for second derivatives. In this second order derivative will come to must be zero in areas of constant intensity, and the second is must be non-zero at the onset and the end of the intensity step or ramp, and third one is must be zero along intensity ramps. So in this condition to be substitution from that following Taylor's series, to approximately will come to analyzation f of x plus delta x equal to sigma n equal to infinity delta x power n dou n power n of f of x divided by n factorial dou x power n. Delta x is the separation between the samples of f. For our purpose, what is the separation of measure in pixel units to be approximately to be analyzation from the type of Taylor series formula. So intensity difference and the Taylor series are first order derivatives will come to substitution from one of the three waves: forward difference, backward difference, and central difference. So in the three waves will come to say this analyzation from that is second order derivatives. Same thing here will be applied from f power f double dash of x. Same the third order or central derivatives will come to analyzation from the third order derivatives. So fourth order derivatives will come to analyzation from that fourth order derivatives. In this example, to similar, what is the group should become to analyzation from first and second derivative? In this case, two types of edges here: ramp edges on the left and the step edges on the right. Already we studied about this the type of four central value. Already studied about this concept of edge direction. Isolated points should also become to analysis from Laplacian rules. Line direction. So what is the role of the line direction? In this line will come to Laplacian kernel. The points will come to this X-ray and then turbine plate with the photosity of this manifested by the single black pixels. This is a dot. That's the help of this Laplacian line direction. This is also original image. Will come to analyzation from the type of this Laplacian image. So magnified section shows the positive and negative double line. Effective characteristics of this Laplacian. to be considered with the type of information among this particular direction. See edge models. So many edge models there for segmentation. You will come to analysis from the type of classified from among this particular group. Depends upon this multiple edges. For example, ideal edges can occur over the distance of 1 pixel, provided there is no additional processing. So here this type of this edge detection role. Especially the first region will come to edge detection role. Now we will move to region-based segmentation. So images like that will come to appropriate from region-based segmentation role. This edge detection already we discussed in this previous chapter, previous image. So now we will move to region-based segmentation. So already study about the thresholding area. Any type of combination threshold is very vital role to be compiled from the type of segmentation role. So in this major role for the edge detection, that edge detection especially to supported from discontinuities of this edge points. So that is the help of this canny edge detection. So already studied about this previous chapter. So mainly to consideration over to our segmentation points. So linking edge points. So whatever this is a major role for linking edges mean. The edge detection should yield sets of pixels lying only on edges. So it will be connected from non-uniform or uniform illumination to connect it to this point of this neighboring pixel 3 by 3. That means local region. So edge points should be linking to one to others. So the type of local pre-processing, local processing will come to analysis from the type of magnitude of these pixels. Here this angle similar alpha. Like that is computing this following steps. Compute the gradient magnitude of the angle arrays m of x comma y and alpha of x comma y of the input image f of x comma y. From the binary image g of x comma y, whose the value at any point x comma y is given by g of x or y, either 1 or 0. If 1 means m of x comma y greater than tm is the threshold value. Alpha of and condition alpha x comma y equal to a plus or minus ta. That is, a is the acceptable directions, specified direction angle. Plus or minus dA is to band acceptable from the target direction, acceptable direction. Otherwise 0. Here come to the here come to edge linking to provide some type of information. So this is the image of the rear of the vehicles. The global processing of Hopf transformation using transform, that is the help of this concept of edge detection role. So now we will move to region-based segmentation. Before the thresholding concept. So normally thresholding is a very important role to be implemented to be separation of this foreground and background. That is this major role from one threshold or multi-threshold concept. So here there is a basic intensity of thresholding concept. So this thresholding is come to analysis for f of x comma y is greater than t means always 1, less than or equal to t means always 0. Now we will come to this concept will come to reference from global threshold, multi-thresholding. So many concepts will come to along with separable of histogram diagram. Intensity histograms that can be partitioned by a single threshold and by dual threshold, T and T1 and T2. The role of noise of image threshold depends upon this, the type of separable of two peak of multi-threshold concepts. The role of illuminations of reflections of image threshold, especially that we come to along with the type of different postures. So global thresholding is a basic thresholding concept to be. In this concept, will come to multiple iterative algorithms to be using here. For example, we select the initial estimator of a global thresholding T, segmented the image using of T in equation. This will produce two groups of pixels. G1 consists of pixels with intensity values of greater than T, and G2 consists of the pixels with values less than or equal to T. Compute the average mean intensity values M1 and M2 for the pixels in G1 and G2 respectively. Compute the new threshold value to identify this mid value of M1 and M2. T equal to 1 divided by 2 of M1 plus M2. Repeat this step 2 through 4 until the difference between this value of T is a successive iteration is smaller than the predefined value of delta T. So in this condition, to identify this global thresholding, it will be highlighted from noisy fingerprint, histogram, and segmented result using from global threshold. Global threshold we using from thin image border added for clarity. So multiple thresholding will help of this Wurtzow method. Already studying in this previous chapters, thresholding concepts. Same here with this repetitive of this thresholding concept here. So the image segmentation to improve the global thresholding. This is using edges to improve the global thresholding concepts. So here this is the type of algorithm to be supported from the type of Laplacian criterion to be identification about this global threshold. Help of this multi thresholding concept Wurtzow method. This is a global thresholding concept will be applied from the segmentation of Wurtzow, multiple threshold. See here multiple global thresholding concepts. So what is the variable of threshold? The analyzation from that neighborhood of the pixels. So variable threshold based on a moving average. So this is the major role from the textures corrupted from this Wurtzow model to be highlighted from the type of the moving average. Second region is segmented by region growing and by region splitting and merging. So in this concept very interesting. Depends upon this objective of the segmentation. Normally the partitions of the image into region based. So this approaches will be attempting to find the boundaries between the regions based discontinuities in its intensity levels. So region growing. As the name, you come to say the region growing is a procedure that the groups of pixels or subregions into larger region based on the predefined criteria for growth. The basic approach is to start with a set of seeds points and from this grow region by appending to each seeds those neighboring pixels having predefined properties similar to the seeds. So in this case, the intensity will come to based on this intensity or color. In this case, you will come to the prior of this text image to be corrected for sinusoidal shading. The next is will come to say the result of the global thresholding using Wurtzow method, and the final the result of local thresholding using moving average. So this is the concept will come to approaches from the different type of methodology to come to region from region splitting area. So in this region, for example, any type of candidate of pixels and the pixel grown in this in this intensity of a candidate and the average intensity of the grown region. In this model, we come to appropriating nearby this the type of seed arrays. For example, let us see here f of x comma y denotes the input image. S of x comma y is the denote the seed image, seed array, because it will be containing from ones at the location for seed point and 0 elsewhere. And Q denote from predicate to this applied of the each location x comma y. Arrays f and s are assumed to be of the same size. A basic region growing algorithm based on 8 connectivity may be stated as follows. See here this finds all the connected components in S of x comma y and reduce each connected component to 1 pixel. From this each and every region based concept here we will like growing method, how to this is each and steps to depends upon this form and image of f of q, and let g be this image to form this appending of each and every seed point of s, and then label each connected component for win g different region every. So these are the things. Will come to example of illustrated the mechanism of this example algorithm segmented by region growing. So in this example, we'll come to say analyzation from what are the subpoints will come to be growing of this particular pixels. Either q equal to true means if the absolute difference of the intensity between the seeds and the pixels at x comma y is less than or equal to t, otherwise false. Say the type of this value here we say the welding X-ray image of defective weld. We highlighted from this histogram of each and every initial seed image. The final seed image, the points are be enlarged for clarity, be improved. So these are the image region growing approaches. Next one, region splitting and merging. For example, here we say the type of seed points. The alternative of the subdivided of the image initially to set to the disjoint regions. So in this case, merge and or split the region it attempt to satisfy the condition of segmentation. So the basic of region splitting and merging are discussed in this next chapters. For example, here we come to R represented for the entire image region and the predicate region is Q. So one of the approaches will be segmented from R from subgroups to be splitted the region from Ri. Q of Ri equal to true. We start this entire region from R. Q of R equal to false, then divide this image into quadrant. If Q is a false for any quadrant, we subdivide it into quadrant into subquadrant and so on. So in this splitting technique as a convenient representation for the form of so-called quadtrees. That is a tree which is each node has exactly 4 distant images corresponding the nodes of a quad tree, sometimes called quad region or quad images. So R4 is subdivided into for information. So what is this drawback can be remedied from allowing from merging as well as splitting. So satisfied this region adjacent region from Rj and Rk to merge with Q of Rj union Rk equal to 2. The preceding discussion they summarize the following procedures in which at any steps we split into 4 disjoint quadrants of the region or Ri for which Q of Ri equal to false. When no further split is possible, merge and any adjacent region Rj and Rk for Q of Rj union Rk equal to true. For example, here this is a splitting of R, say R2, R1, R2, R3, R4. But here this is again subquadrant for R41, R42 and R43, R4. How do you splitting this corresponding quadtree? Here R is a major, R1, R2, R3, R4. Again R4 be splitting into R41, again 4 group. So in this stop, no further of a merge is possible. So in this case, here we say segmented from splitting and merging. So here this image of a sinus loop of a supernova taken the X-ray band of NASA Hubble telescope. There is a region of a quadtree. We will come to approaches from the type of region of splitting and merging. So in this chapter we say this the type of information so regarding with the region based segmentation. segmented by morphological. Here we come to say the next topic. The region segmentation using clustering and superpixel is also region-based work. Here the region segmentation using k-mean, clustering, partition clustering, help of this centroid position, the value of initialization of the algorithm assigns the samples to the cluster, update the cluster center, and the means and the test completion will come to along with the type of it, which one is this least the equilibrium distance, then it will change over to the type of centroid position. So that is this number of iterations we come to along with the iteration level of increase. That is the drawback for k-means algorithm. So region segmentation using superpixel means you'll begin the superpixel to highlight it from selective pixel that is dominated from the particular image. It will become to allocate it from the type of images. This is the image representation from the type of 600, 400, 480, approximately 4,80,000 pixels. Image is composed by 4,000 super pixels to be highlighted. This is this resultant pixel image, super pixel image. So the resultant to highlight from this darkness and lightness, which one is more complexity of this particular image. So this is the region-based pixel link. Another one is SLIC superpixel. SLIC means simple linear iterative clustering. So this algorithm to be supported from the type of dimensionality. So initially this algorithm assign this cluster center and update this cluster center and test for convergence and post process from superpixel regions. So these are just the major analyzation from the type of distance value. So these are the image segmentation role. Another role from region segmentation using graph cut. Normally in our practical problem we will say this is a graph cut algorithm. What is meant by graph cut? The optimum partition is called the cut of the graph into this group of nodes. It's called a graph cut. Optimality based on the criteria whose the values from highest I of our members within the group, that is called a region. So and low across the member of a different group, as you will see the later in the sections, graph cut concept. So this is say that the type of image of pixels. So each and every group should become to analyzation from this partition k-mean algorithm. So in the C part you come to say the type of image from the 100 elements of superpixel showing in this boundaries for reference. D is will come to same image with any boundaries. E is a superpixel image that segmented from the k-means algorithm. So image as a graph. How to say this image as a graph? So graph is a G, the mathematical structure of a set of V. V mean vertices. So or nodes. V of nodes, vertices and the edges. E is the edges. So normally the vertices will be connected comma edges G equal to V comma E. Vertices mean edges and belongs to subset or equal to V by V. That is a pair of these edges. We will come to these elements. So we will say this is a directed graph or undirected graph. So in this cutoff graph, we will come to say another A union B of equal to B and A intersection B equal to null edge. So in this state commanded from that is the type of process. We will come to node we allocated from the 3 by 3 is image. A corresponding graph cut segmentation from image, either node or edge and graph. We cut off these things will come to say the type of image partition will come to say remaining parts will come to black. So in this called will come to say the two additional nodes will called source and zinc terminals nodes. So this is this major role from cut off this background area or foreground area. So minimum graph cuts will come to supported from this expressed as a graph will come to analyzation from the type of minimum graph cut. So called maximum flow or minimum cut theorem. You cut means you come to say the sink from the source. So that's the image, source or terminal graph. How to this cut off this image from source, terminal, background, image and segmentation. Zinc terminal is the foreground and the zinc terminal is the foreground. How to be cutting from the particular area. So that is a minimum cut. That's a more meaningful cut. Proximity such as the partition shown in this figure will come to presented over this, avoiding the segmented region of this cut. Normalized cut for n cut. Out to this way, this is a comma b. Cut of a comma b divided by associate of a comma b plus cut of a comma b divided by associate of b comma b. Finally, the association will come to analyzation from the type of computational of the n cut. Computing from minimal graph cut to be supported from the k dimensional indicator. It is supported from the type of Shri and Malik in this year 2000 to analyzation from the different type of graph cutting algorithms. So that is this stability of this type of graph cut algorithm. Graph cut segmentation algorithm depends upon this equation. First, given the set of features specified from weighted graph G equal to V comma E. In V contains the points in the feature space and E contains the edges of the graph. Computing this edge weighting to constructing this matrix as V and D, let K denote this desired number of partitions on the graph. Solve the eigenvalues of the system D minus W y equal to lambda dy to find the eigenvectors with the second smallest eigenvalues. Use the eigenvectors from the step 2 to bipartition the graph by finding the splitting point such that n cut a comma b is the minimized. If the number of cuts has not reached k, decide if the current partition should be subdivided by the checking the stability of the cut. Recursively, repetitions of the segmented part if necessary. So this is the major role for graph cut algorithm. Should be implementation from the type of a program. So after this is implemented this program. For example, I will open for this program. So open CV, I think open CV. Open the source and then samples Python, and I will be taken from GraphCut. So in this GraphCut algorithm, is one of the practical exercise here. See here, I think sixth problem. Write the Python program using GraphCut algorithm to extract foreground image, interactive from foreground extraction. For example, here that program will be open here, Python, GraphCut algorithm. You open here and then run this problem. See, this is the messy, is a foreground picture, background is audience. So I will show only this messy pictures. So press left button, right button, and then select it here, and then press N, and the selected pictures is not be clarity among this the sand is not be protected. So at time you will be using from initially 0, you will be pressing here, sorry, 1 pressing here. I will show this area of this point. Okay, so in this area I highlighted from all the areas. So formally the shoes are there, and then location of the shoes and pointing here, and this background will come to like that 0 here, pressing here I will be omitted this range from the type of background area. So this is called a graph cut. So normally the resultant will be shown here. So normally that is a cutting of this area. So for example here, this is a shoe here. Normally how to this mapping from the type of a graph cutter. Clear? So students, this is a very simple program. How to elaborate from this graph cut algorithm. Just I am posing here. Okay. Thank you for presentation of this fifth unit. At the conclusion from next topic, I'll move to segmented using morphological watershed. Thank you. Good morning, students. Today the continuity of this segmentation topic, the region-based segmentation, where the part of this segmented by morphological watersheds. Normally, that segmentation is the partition of this multiple regions. In this each and every region depends upon this to fill or close, and then some type of shapes should be to be corrected. That is the help of this segmentation. The three principal concepts: edge direction, thresholding, and region extraction. In this main concept of each and every approaches, have advantages. For example, speed in case of global thresholding, and the disadvantage, for example, need for post processing such as edge linking in edge based segmentation. In this section, we are approaches from the concept of called morphological watershed. Here, segmentation by watershed embodies many of the concept of this other three approaches, such as more stable segmentation result, including connected segmentation boundary. This approach is also provided a simple framework for incorporate the knowledge based constraints. In this segmentation process, we can discuss in this section what is the background study of this watershed approaches. This watershed is based on the visualize of image for 3 dimension, 2 spatial coordinates versus intensity. So in such a topographic interpretation, we consider 3 types of points. First one is points belong to a regional minimum. So points at which a drop of water is placed at the location of any of those points could fall with certainty of the single minimum. The third thing is points at which water could be equally likely to fall to more than one such minimum for a particular regional minimum. So the set of satisfied condition is called catchment basin or watershed of that minimum. The points satisfying the condition, they form crescent lines on the topographic surface and refer to the divide line or watershed lines. The principal objective of the segmentation algorithm based on this concept is the find to watershed line. You can approaches from the different type of topography image, being this enclosed by dams that are this higher than the highest possible mountain. Suppose we can hold in this punches for regional minimum, some type of will come to darkness area. So entire topography the flooded from this flooded from the below of the letting water rise through the holes at the uniform rate. The first stage of flooding where the water shown this light gray has covered only area of the correspondent to the black background in the image. Next, the remaining pictures we can show this the type of information. For example, here this is the original picture. The second thing is the topographic view. Only the background is black. The basins on this left is slightly to be lighter than black. C and D, you say this water should be spread over to that is area. It will come to along with the type of flooding. So in these cases, what will we say? Some type of issue. For example, here, um, paint brush. I will open here. See, some type of this value to be shaped. Okay, this shape. Some type of this curve lines I will be drawing from here. Some of this pencil I will be drawing here. Now you fill this first I fill this open color here. So what will happen? The remaining that area should become to fill, but the closed area to fill with a different color. Those, so that like that area, what will we say? That is this closed area. This is a large area. We'll come to the type of the issue here. What will happen from the different type of watershed? We located from different type of this. Right here, see. All we know understood what I say that the type of color will be boundary from that area. Clear? So that is a major role from that is area. You come to this watershed. What will be happen from the type of this color or this is filling this color that like that's the water. That is the area should be coverage from that is the located from the particular thing. See the same thing will come to filling this here. The light gray, the water will flow of this gray. You come to say that location of this circular locations. So whatever anything will come to moving from this surrounding this light gray represent this water, and along with the type of this information to be easily to classification among this particular segmented of this particular road. That is a nearly uniform of this type. We'll say the type of this result of this further flooding. Depends upon this water, say beginning of this merging of water from two catchment basin and automatically to longer dam. So final watershed of the segmentation lines superimposed on this original image. So here this is a water imposed of this original image. So this is a major region to come to a type of image. So this is a dam construction. The dam construction is based on the binary images. You come to the based on 2D integer space. Z square. The simplest way of this information of the dam separation stage to be a mathematical analysis of this that flooding specs of a basin. Step n-1. The introducing this shortly m1 and m2 denoted this sets the coordinates of these points to two regional minima. The points will come to the catchment basins associated with the two minimum at stage n-1 of the flooding be denoted by C of n-1 m1 and C of n-1 of m2 respectively the two gray region. So here we say the type of this information along with the watershed segmentation. The original origin will come to this the first dilation, second dilation, the dam point. For example, in your locations you will come to analyzation from the type of information. Our mathematical representation of this program, you will come to say the type of information along with Python language, how to spread out the watershed segmentation with different type of colors and be forced with the informations. I will open this open series. Source, samples and Python. I will open this watershed, open to edit with ideally method, already have a registration from Python 3.8 in your system. So I will open from that is watershed segmentation. Here the simple program, so what is this color fruits 1.jpg I will open here. How to this is watershed will be written from this fruits 1 underscore watershed dot jpg. I'll simply run the program here. What are the conditions will be displayed in this shell window? The shell window will be marking with 1 to 7, the switch marker color, and the space mean updated segmented, R mean reset, and A mean toggle auto updated, and then escape from character mean exit. So now we'll open from this fruits1.jpg image. Yeah. I think Sachin image will be open. Okay. I think close the shell. Fruits image I will be open here. See, I will be blocking with the Sachin image. Okay, already I'll be open with the two type of program, Sachin and fruits. The location of the border is very important from intent of this work. CV fruits.1.jpg. Self comma dot fn self image comma cv dot color pgr to rgb is correct. I think what will happen from that work, outer intent level. Okay, I'll be moving from here. This is intent. Carefully you will come to save from that image. Okay, just run this program. So I think something will be wrong because compiling from customizing from that error again save. Because here this is expected from function is Sachin only to force here, so that is a problem. Sachin, yeah, that will be okay. Now FNS will come to fruits, correct. Now we will come to say that fruits is there. See here, simply press 1. Here this color we say here marking from that watershed. So here this is a resultant of watershed. So this is the original image. Now press 2. I will be marking here from a green color, correct. Next press 3. Here I located from that place. Here watershed we move. Press 3. So already press 3 is there. Press 4. See 4. Press 5. Press 6. Press 7. Okay. There are different color. First color, second color, third color, and fourth color, fifth color, sixth color, and a seventh color. So 7 colors will come to this watershed. Now you'll become to update this segmentation. Just like the space bar, you'll come to update this segmented. Otherwise, press or you'll come to reset this application. Press A, that angle will be auto off, or again press A on. Again escape means escape of the images. So automatically, why to say the type of information to be storing with the color with the watershed segmentation. It's also the same called as color segmentation. So in this two partially of this flooding, first dilation, second dilation, morphological application. So in this morphological application, especially erosion and dilation, this major approaches from the type of a watershed algorithm. So that the watershed will come to applicable with the morphological, so morphological watershed. So this watershed segmentation algorithm commonly here we say this the type of M1, M2 up to MR, it is denoting the coordinates of the point in the regional minima of an image G of x comma y. As mentioned earlier, this typical will be the gradient image. Let us C of M of I. So in this connection, the notations of minimum and maximum will be used to denote the minimum and maximum values of G of x comma y. Let T of n represent the set of coordinates s comma t for which G of s comma t less than n. That is t of n equal to s of s comma t given that of G of s comma t of less than n. So geometrically T of n is the set of coordinates of the point in G of x comma y lying below the plane G of x comma y equal to n. The topography will be flooded in integer flood increment from n equal to minimum plus 1 to n equal to maximum plus 1. So in this concept you come to say the type of information in this paragraph of binary image will come to given by this C of Cn of m of I equal to C of mi intersection of T of n. In these cases, you will come to flooded catchment basins at stage n, and let C of n denote the union of the basins at the stage, and then that is a maximum plus 1 is a union of all catchment basins. So this is a basic criteria of this watershed algorithm. There are three important possibilities. Small q, you will come to say intersection of C of n minus 1 is empty. Q of intersection of C of n minus 1 contains one connected component of C of n minus 1. Q of intersection of C of n minus 1 contains more than one connected component of C of n minus 1. So this is a major three importance from based on this the type of a watershed algorithm. The use of markers. What is this use of markers? Already say this here 1 to 7 markers in our program. Say here the same help of this segmented watershed to be highlighted from this marker to this internal marker and external marker. Depends upon this associated with the background external marker. Internal marker is the internal part to be highlighted from this low internal location. The two principal steps will be there. One is pre-processing and another one definition of set of criteria that marker must satisfy. So this is a major reason from the type of this image of blobs, image gradient and the watershed lines superimposed on this gradient image and the watershed lines superimposed on the original image. So this is highlighted from this the type of information to be cross over this the type of watershed application. So electrophorese image, the result to apply the watershed algorithm to the gradient image will come to force with the type of this located from segmented region only. So it is another type of image showing the internal markers light gray region and the external markers of watershed lines. So the result of the segmentation will come to improvement of this segmented. So the use of motion in segmentation. So motion is a powerful cue used by humans and many animals to extract objects or regions of interest from the background of irrelevant details. In image applications, motion arises from the relevant displacement between the sensing system and the scene being viewed, such as robotic application, autonomous navigation, and dynamic scene analysis. In the following discussion, we'll come to this motion in the segmentation both spatially and the frequency domain. Spatial techniques, a basic approach will be there, and accumulated difference. So here the ADIs will become to display from the rectangle object moving from this southeasterly directions. So first one is the absolute ADI. So a positive ADI, this is a negative ADI. Establishing a reference image. The frequency domain technique will be highlighted from the type of a low pass and high pass filtering technique. Here we say the static in reference of that is both A and B, and east bounded automobile subtracted from A, and the background restricted from the corresponding area in B. So that concept will be application from Fourier transformation 1D and the Fourier Fourier transformations to apply it with the Landsat. So the Landsat frame will come to say applied from the different type of a phenomena. The intensity plot of the image with a dark circle. So there's a major reason from image segmentation. The role will come to application from the different concepts. So already study about this both out of this motion in segmentation, image segmentation based on this colors. So everything will be discussed in this image segmentation role. So students, in your role, what is the major color or dimensions or motions will come to say in your theory of assignments? You will be preparing very well to image segmentation. What are the image techniques are there? How to this image to apply it from the various application segmentation, and what are the algorithm, especially be forced with any 5 algorithm to be written here, and also maximum minimum your 20 pages will be written from this assignments. Tomorrow is the last stage. Thank you.